Hello everyone and welcome to another video. In this one we will start to program the server, right? In the previous one we basically did some terrain generation using midpoint displacement. It's generating very nice terrain in my opinion. And while I was editing the video I realized why this was not working, because here I actually need to initialize this stuff like this, right? So this is my delta. So if I do something like this, I have to add the displacement to the sea level, right? I cannot set the displacement right away. So that was the issue. So if I say delta like this, and if I move delta upwards, this should already create something. Yeah, that is working. As you can see now, the start and end of the segments, they no longer need to be at sea level. They can be like displaced and stuff like that. So let me just make it a little bit more like smooth. Okay, I had some notification in my bar, whatever. So yeah, I think this is, oh my god, okay, I think this is now working properly. As you can see, the end of the segment is much higher than the beginning of the segment, and we have like a more natural terrain. Cool. But now we need to start programming the server. I'm not going to do a complete server for now. I'm just going to start like the boilerplate code with libuv. So let's come here and we can say libuv example TCP echo, something like this. We can probably take a look at some examples. Yeah, that's a small example. Yeah, so let's start it, right? Let's start it. We can create a new file, call it server.c, and now we just need to start programming, right? So the first thing I want is to include standard lib and libuv probably. Oh, it's actually uv.h, yeah, uv.h, and here I can simply return exit success. Oops, exit success. Right, so libuv as by the way, libuv is the backend of Node.js. It's basically what Node.js uses. Not only Node.js but also Lua and stuff like that for async networking and file access and stuff like that. It also has thread support, it has thread pools, it has a lot of stuff, right? So it's a very complete library, and it is pretty fast because it is single threaded, which is an advantage, by the way, for us. We can actually make it multi-threaded. It's relatively simple to do it multi-threaded, but I actually want it to be single-threaded, and internally it uses the epool and stuff like that from Linux and Mac OS and Windows. I can open the docs. So basically it is used for asynchronous I/O, and this internally uses, where is it? Can I search for this? Is it going to give me any results? Yeah, it basically uses epool, KQ and IOCP and stuff like that for the network communication. So it's very fast, right? It's very fast. It uses native OS stuff. So yeah, that's basically it. So if you want to take a look at it, you can. I'm going to put the docs in the description, okay? But basically libuv is based on an event loop, and to use it we always need to use a loop t like this, and we can say this is a loop. It generally uses a lot of pointers, right? And that's why I spent like 14 episodes just, or not really 14, more like 12 episodes just creating this demo lib, this base.h, so we can get a more or less clear idea of what it needs to be done to have like a good memory management system with pool allocators and arena allocators and stuff like that, because that's one of the disadvantages I would say of libuv, is that it uses a lot of allocations, like a ridiculous amount of allocations, right? So I need to be careful with that. But yeah, so libuv has this UV default loops thingy that it just returns me a default loop. And basically here I can say UV run, and this is basically going to run the loop, right? And the loop, it has multiple modes, and for the server I actually want a default. Basically default basically blocks the execution and waits for everything to be handled, and it keeps waiting for new events, right? No wait is just going to execute whatever event is in the queue and then terminate, and once is basically going to have like a period where it waits for new events, but after that timeout it's just going to terminate as well. So we want to run continuously without ever terminating, so I want UV run default, right? And if I'm not mistaken, this is going to return me. I think this follows like the Unix way of doing things. So if I say UV run, or is it? What does this return? I don't remember very well. What does this return on error? Let me see. So it also doesn't tell me, which is I don't want any of this. So I can assume it returns like less than 0, or well, let me assume that anything that is not 0 is an error, right? Let me assume that. So yeah, I can say UV run, and here I can say something like error, and I'm going to need to include stdio, of course, right? And here I could say could not run. Yeah, I basically could not run, and I can add the error. I know that libuv is something like str error or something like that. Yeah, so it needs the error itself, so I can probably extract the error using something like this, right? So if I do something like this, and if there is an error, then I can basically do that. Cool. And here I can probably just return exit failure. Cool. So for now, I think my game is going to be just TCP, just to be simpler. And I know usually UDP is used for games, but people forget that UDP gets deprioritized in network traffic. And I don't think that TCP is that bad right now for casual games, right? I know that for competitive games you need very special stuff, but this game is going to be very casual, right? So I'm just going to use TCP for now, and I can modify it in the future, right, if it's needed. So I'm basically going to need to initialize my TCP server, and this is going to be just TCP/P. I can call it server, right? I'm just following this example. I know how to more or less what I need to do, but I don't remember exactly, so I'm just going to follow what this example tells me. So then I need to initialize it. This is actually TCP init, and this accepts a loop and the handle, which is a pointer to server, right? Yeah. And TCP init can also return an error, so I can just say something like that. So one thing that I want to do is to basically manage errors properly. Could not init TCP server. Okay, so I know exactly what is going on, right? This example doesn't do it, but I want to do it in my code. Right, then we need to bind an address, so I can do IP for address. Is it? Yeah. And here I need the IP, and for now I can use my local or LAN address. This is going to work on LAN, if I'm not mistaken, so everyone connected to my router will be able to connect. And then I need a port. What port am I going to use? I don't know. Let me think about something. 3245, whatever. And then I need actually a structure for the address, right? And where do they have this? Okay, so they have this here. Oh, I know one. Okay. See, yeah, because this needs to be well, but this should probably work, right? Yeah, I think so. I don't think this needs to be global scope, but we can change that if it is needed. So this is actually from Unistel, if I'm not mistaken. Or is it? This is IP types. Well, let's assume it exists and I don't need to import anything, right? So I can say just address. Cool. And this also returns an error. So we can check for that error. So could not bind IP address, right? Cool. After binding my this is actually create or something like that. Could not create IP address or something like that, because now we actually need to bind it. So is it called, okay, it's called TCP bind, and this basically accepts an handle which is a pointer to server, and it accepts the address, and then it accepts some flags, but I don't think I need flags, but let me check it. Yeah, I can just pass 0. Cool. And this also returns an error, if I'm not mistaken. Yeah, so we can always check the errors. Could not bind IP address. Cool. And after that, the only thing missing is to listen, right? Yeah, it says to listen. So yeah, you can say uv TCP list, or was it? Oh, just listen. Okay. So here I need a stream, and my stream is a server, right? But here I need to cast it probably. But let's see. I know that UV has something like max something that gives me the maximum amount. What does this need? Backlogging. I can put 128 for now, but I know that there is a constant in libuv that gives you the maximum supported by the OS, if I'm not mistaken, but I can change that in the future, right? So here I need a callback, and my callback has this signature, right? Has this signature. So this, okay. So this is basically going to be on connect, right? Then I have the server, and then I have the status. Okay, cool. So if I do this, right, and this may also return an error. Could not listen. And then this is basically going to queue it, and this is going to run and listen to connections and stuff like that, right? And write requests and stuff like that. I think that's more or less everything, to be honest. Yeah, they are using run default as well. Cool. So now on connection, we basically need to check for the status. And apparently, if the status is less than 0, we have an error. So we can just say could not connect. Right, I think that's it. So here we have the status. I think we can provide the status. Yeah, we can provide the status to that function. And when we cannot connect to the client, we just return. Right, we don't want to continue executing. And then they basically allocate a new client, and this is my first thing. So I probably want to use my pool allocator here. I would guess indeed. So do I have time, by the way? yeah, I still have a little bit of time. Okay, so I can basically, here I should be able to include app slash base.h, and here I can define base implementation. Let me just copy the thing. I don't know if I'm going to keep this lib like this or I'm going to split it, but well, the API is going to be more or less the same, right? So I can basically say pull. I can basically say pull and yeah, let me just call it pull for now. And here I need to initialize it, right? So I need to do something like pull, make pull, because it needs some stuff inside it. Right, and here I basically need to allocate a UV TCP client, right? And this is basically we just need to allocate. So here I'm going to say pull alloc, and I need to provide my pool, which is the global one, and here I want size of and this is probably just this thingy. Well, but I can just use this trick, right? So this is probably more less error prone, right? And this is going to allocate me the client. I don't know what's the size of this. I'm still pondering if I should actually have this splitted by like this, or I should just have a single array with different size blocks. I need to think about that, or whatever. So I can just do UV TCP init. Right, I can do UV TCP init. Oh, and that's one bad thing. Well, but yeah, that's one bad thing, because I probably don't want to assert that memory got allocated, because then it's going to crash the server, isn't it? Yeah, well, but in release mode the assert doesn't work. So if in release mode the assert doesn't work, it's not a problem, right? Because it's not going to crash. Well, but yeah, whatever. I need to think about that. I'm probably going to change this specific implementation for this case. Okay, but here I provide a client and I need the, well, actually need to provide a loop. Oh, okay. So this is why they put the loop, globally, because you actually need the loop, right? Globally. So here I can put the loop and then the client. And once again, this can return an error. So we can just check it, right? So could not init TCP clients, right? And here I can just return, no big deal. Okay, so after initializing the client, I need to accept the connection, right? I need to accept the connection. Here they start reading right away. They start reading right away. Do I want? I'm probably going to leave this for the next episode, right? I don't want to do this now. So I just want to accept the connection. And here I need the server, and the server is this stuff. Cool. So the callback provides me the server, and I want the client. And here I can just say, check for error once again. Here I could say could not accept TCP client, whatever. And here if I couldn't accept the connection, then I need to close this. So I probably want to do that, right? And on close doesn't need a callback, so we can provide that. Okay. Then if I accepted the connection properly, I could start reading, right? Or do something else, right? Or something else, right? But I don't want to do that in this episode. So here I'm just going to print something like info connection accepted, something like this. And I just realized I forgot to add a new line at the end of this stuff. Okay, so this is probably more or less what I need. I would say so. So let me add this new command to my build tool, and here I can just say this is my server, and I need to copy this server, and here I want to compile server and include folder. Yeah, I can include that entire folder. C flags are the same. Link, yeah, I can link the entire folder, but here I just want libuv. I don't want reliv, right? Because I don't need reliv for anything inside the server. The reliv is just client side, right? Okay, so here, if now I try to recompile my build tool like so, and now I build everything, do I get any errors? Yes, I do. Okay, so line 25, this expects, it's an incompatible pointer. Why is it? So this accepts, oh, it accepts a UV stream. Okay, so I can probably just cast it, right? I can probably just cast it. What did they do here? Oh yeah, they just also casted it, so not a big deal. If I build again, they need another kind of pointer here. They need, well, but this is what I socket address in. What are they complaining about? Oh, they okay, UTC binds. Oh, they need a const struct address. Okay, so I can probably cast it to that. Sock address pointer. Let me see if this works. Okay, it worked, and now line 62, it's also another thing. What does this expect? This expects another stream, so I probably just can just cast it again to a stream in listen, and this should also work. Let's see. Okay, at least it built correctly, right? Let's see if this runs. Let's see if this runs. Yeah, I need to allow that because that's firewall stuff from Windows. Oh yeah, I probably, now how do I test this? Well, I can probably, oh, but if I do this, is this going to crash? No. Okay, cool. So yeah, is it requires a lot of stuff here to make a client? Yeah. Well, I can probably just do some quick thingy. Yeah, let me just do this very quickly just to test if the server is like properly doing stuff. So for now I can just do this and just do that, and then I can quickly do this. So this requires libuv, right? And libuv actually conflicts with reliv, which is a shame because reliv doesn't have name spacing and it screws up. It screws up libuv, right? But whatever. So here on connect, I don't want anything on connect. I just want to connect to the server once and see that, right? Because this just reads the buffer and stuff like that. Okay. So I need to use the same ports. I can put that into a separate config later, but yeah, that's basically it. We just do a loop, we create a socket, we initialize it, we connect, right? This is a connect request, right? Yeah, we can just do that, whatever. So if I rebuild everything, and here I'm going to need, well, it doesn't really matter because this is already built executable, right? So I can just say this is desktop. Oh, but this is Windows stuff, right? So I can, what can I do this? Can I do, okay. It doesn't autocomplete. Okay, universe. Okay. Oh my god. Do I have clear? I don't. Do I have I don't? Okay. But yeah, so here I can run the server, and the server is running. And if I run the client, oh, because god. Okay, the client has run, and you can see, right, connection accepted. So the server actually got the connection, which is cool. So we were able to make a server first try with a little bit of help. I can also put that in the description, right? I think this person deserves a credit because it's actually pretty useful, right? So this one is very useful. You can base yourself on this one. But yeah, so the client basically connected to the server, then it just terminated, and the server was able to accept that connection. Cool. And I think that's everything for today. I think we can work on something else later. So yeah, that's the basics of the server. We are using libuv. It seems to be working correctly. We can actually use now the pool allocator. I may change the implementation a little bit in the future, but for now we can keep it like this. And so whenever a client terminates the connection, right, and for buffers and stuff like, and requests, since libuv uses heap allocated memory for all of that, we can just keep reutilizing the same memory whenever those get inutilized, right? Okay, so thank you for watching, and I see you in the next one.